In this chapter, we're going to be discussing Chapter 7, which is the normal probability distribution. Normal probability comes from continuous data. Remember back in Chapter 6, we talked about discrete data, countable data. In this chapter, we'll discuss the distribution of data that happens to be continuous, or intervals. In the first section, 7.1, we'll talk about the properties of the normal distribution first. We will start with a discussion of the uniform probability distribution. This is an easy continuous distribution. For example, let's imagine that a friend of yours is always late. Let the random variable x represent the time from when you are supposed to meet your friend until he actually shows up. Suppose your friend could be on time, which is 0, meaning they're on time or 0 minutes late, or up to 30 minutes late, with all intervals of equal time being equally likely. So the random variable x can be any value in the interval such that x is any number between 0 and 30 inclusive. Since there are an infinite number of possible outcomes, any specific probability is going to be 0. Like, for example, the instantaneous probability that he is exactly 29.2 minutes late is 0. But if you give an interval somewhere between 29 and 30 minutes, then we'll have a probability and a value to assign to that. So when we compute probabilities of continuous random variables, we do so over an interval of values. So let's discuss the definition of a probability density function, and then we'll come back to this example. A probability density function, or PDF, is an equation that is used to compute probabilities of continuous random variables. It must satisfy two characteristics. The total area under the curve of the graph of the equation over all possible values of the random variable must equal 1, or 100%, same thing. The height of the graph of the equation must be greater than or equal to 0 of all possible values. Remember, probability is always a number that is greater than or equal to 0, but it must be less than or equal to 1. So the area under the graph of a density function over an interval represents the probability of observing that value of the random variable in that interval. So let's look at how we would describe the above example. Let's think about the previous scenario and draw a picture depicting the situation. If I were to draw a histogram of the above example with my friend that is always late, remember you always put your variable down here at the bottom. In this case is time in minutes. The probability is always going to be on the vertical axis. The time that he can be late is going to range anywhere from 0 to 30 minutes. And the probability are all going to be equally likely that he might be late. So the likelihood that he'll be between 0 to 1 minute late is a certain probability. The likelihood he'll be between 1 to 2 minutes late is going to be the exact same probability. The likelihood he'll be between 2 and 3 minutes late is the exact same probability, and so on and so forth, because it's stated up above that these were all equally likely. So you can see that this is going to be what's called a uniform probability distribution, where all of the probabilities are equally likely. So each interval of 1 minute long has the same probability of occurring. So let's look at the individual probability. So for example, if I wanted to find the probability that my friend might be between 2 and 3 minutes late, for example. What is the area under just this bar? Well, let's talk about the area underneath the whole curve first. Remember, we discussed that area underneath a curve totals 1. So this whole big rectangle under this curve is going to be 100% of the curve, or a probability of 1. And then we split this box up into 30 intervals. 1, 2, 3, all the way up to 30. My last one would be my 30th interval. So if we take the total probability that is 1 and divide that by 30 possible intervals, the probability of each individual box is going to be 1/30th of a probability, or 1/30th of the area of the curve. So if we wanted to find the probability that your friend is going to be between 10 and 20 minutes late, up here on the graph you would have 10 and 20. You're going to have 10 bars in there, of which you got to find the area in between all of those bars. Since there's going to be 10 total bars, the probability that your friend will be between 10 to 20 minutes late inclusive is going to be 10 bars times the probability of each individual bar is 1/30th. So you're going to get 10/30ths, which reduces to 1/3. So we can call this 33.3%. If it is 10 a.m. when your friend is supposed to arrive, and there's a 30% probability your friend will arrive within the next blank minutes. So again, I'm going to go up to the curve and I want to look for if it's 10 a.m. right here at the beginning. So this is 10 a.m. and this will be 10:01, 10:02, 10:03, and so on, all the way up to 10:30. And it says what is if there's a 30% probability, I already know the area under the curve. I know that the area under the curve is going to be 30% of the curve. So I want to know how many of these bars is going to be 30% of the total curve. In other words, where would I end so that way all of this totals 30% and the rest would be 70%, and at what time does that happen? So basically I'm looking for the probability that x is going to be less than some number. I don't know what that number is going to be, but I do know however many minutes that is. When I multiply that by 1/30th of each bar, it's going to total 30%. So all I have to do is solve for that variable. So I'm going to multiply both sides by 30 and then I'll have my answer. So when I multiply both sides by 30, I'm going to get that the question mark equals 9 minutes. Let's recall an example that we looked at earlier, and it says that monthly charges for cell phone plans in the U.S. are normally distributed with a mean of $62 and a standard deviation of 18. Draw a normal curve with the parameters labeled. Then find the probabilities using the empirical rule, the 68, 95, 99.7 rule, of obtaining a cell phone bill that is less than $44. Okay, so the first thing we need to do is we need to draw the curve. You know what? I'm sorry, I skipped a page. So sorry about that. Let's go back. So far more interesting than continuous distribution that we are going to talk about is the normal distribution. We say that a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram is the shape of the normal curve. The normal curve generally is going to look like a bell-shaped curve like this down here. There are some properties about this normal curve. It's going to be symmetric about the mean. So down here you'll see that it has the mean in the middle. Mean is designated by the Greek letter mu. Also, the mean, the median, and the mode are all equal to each other, so the curve has a single peak at the highest point. So right here in the middle you can see that this is going to be the mode because it's the most frequented observation. It's going to have the highest probability. It has inflection points at mean minus a deviation and mean plus a deviation. Remember, sigma stands for standard deviation. Inflection points means when it changes from concave to convex. So right about here and here is when that happens. You'll see that this is convex and then it turns to concave. So right here is going to be an inflection point, and that happens at the mean plus 1 standard deviation and mean minus 1 standard deviation. The area under the total curve is 1. The area under the curve to the right of mean equals the area to the left of mean, which is 1/2. So this side of the graph is 50%. This side of the graph is 50%. As x increases without bound and gets larger and larger, the graph approaches but never reaches the horizontal axis. As x decreases without bound, the graph approaches but never reaches the horizontal axis. So over here, as x gets larger and larger and larger, you'll see that this graph is getting closer and closer and closer to the x-axis, but it never actually touches the x-axis. Theoretically, the x-axis and the graph go out forever and ever and ever, and there will always be space in between them. The empirical rule states that approximately 68% of the area under the normal curve is between 1 deviation less than the mean and 1 deviation greater than the mean. So let's show that in red right now. So 68% of the data is going to be between 1 deviation less than the mean and 1 deviation greater than the mean. Notice I could also split those up into 34% each if I chose to. Approximately 95% of the area is between 2 deviations away from the mean. So if I go all the way out to 2 deviations away from the mean, that would be all this area underneath the green curve. So if the middle is 68%, that would leave 13.5% in each of these tails here in order to total 95. And then lastly, 99.7% of the area is between 3 deviations of the mean. And notice that they all say approximately. These are not exact numbers. So 99% would be everything from this tail all the way out to this tail out here. So everything from 3 deviations less to 3 deviations more. And that's going to total 99.7%. So since this is 95% in the middle, that would leave 2.35% for each of these tails, which then leaves 0.15% in the little tails on the very outside that didn't include in our empirical curve. So suppose a random variable x is normally distributed like above with a mean and a standard deviation. The area under the normal curve for any interval of values represents either the proportion of the population with that characteristic or the probability that a randomly selected individual from the population will have that characteristic. We can describe them either way. Proportion and probability in essence mean the same thing. Other key words besides probability or proportion would be chances, likelihood, percentage. All of those would mean the same thing in the same context of the question. Okay, now on to the question that I started to do when I skipped that page. Monthly charges for a cell phone plan in the U.S. are normally distributed with a mean of $62 and a standard deviation of 18. Draw a normal curve with the parameters labeled. Find the following probabilities using the empirical rule. So first thing we're going to do is we're going to draw a curve. Okay, so over here I'm going to draw a curve that works for all of the questions. So we know in the middle is going to be the mean, and the mean is 62. Then out from there, I'm going to draw standard deviations of $18. So I need to go out 1, 2, 3 deviations to the right, and 1, 2, 3 deviations to the left. And to get the numbers that are associated with each of those values, I'm going to add or subtract 18. So 62 plus 18 is 80. Then plus another 18 is 98. Plus another 18 is 116. Now to the left, I do 62 minus 18, which is 44, 26, and 8. Let's go ahead and fill in the values from the previous page. If the middle two boxes are 68% of my graph, that means each individual box is going to be 34. If the middle four boxes total 95%, that means these must be 13.5. If you added all those together, you get 95%. If the middle six boxes total 99.7%, that means these boxes must be 2.35. And if the middle 99.7%, that leaves a 0.3% to divide amongst these outside two boxes, which is going to give me 0.15%. And if you added all of these up, you'll get 100%. So this is going to help me in answering these questions on the left. So the first question says, find the probability using the empirical rule, which I've already labeled it here, of obtaining a cell phone bill that is less than $44. So this is how we would describe that. Find the probability that the random variable x, in this case which is a cell phone bill, is less than $44. So first thing we're going to do is we're going to draw this independent little curve here. Okay, it's going to look like this, but I'm just going to take out the important information. Okay, we know that 62 is in the middle and 44 is over here on the side. So I'm looking for this part of the graph that is less than $44. So I'm trying to find this area that is less than 44, which would be on the big curve, it would be just this portion of the graph over here. So I would add up those three values, because that's the area that's shaded over here. So I would add up these three values, which is going to be the area of this curve. And if you add up those three values, you're going to get 16%. Let's try the next one. The next one says find the probability that the random variable x, or that a cell phone bill, is greater than $62. Well, again, let's look at a mini curve. $62 is right here in the middle. This middle mean is $62. So I'm going to find the area that is greater than the mean. Because remember, $62 is the mean. So that's exactly halfway in the middle. So if I look at my graph over here to the right-hand side, I'm looking for this area of the graph over here, which is to the right of 62. So I'm going to add together those four values, which is going to total 50%. And you probably picked up on that already since it was exactly half the graph. Anytime you have mean as one of your data values, it's going to lie right in the middle. How about the probability that x is at least $98? The question is, what does $98 and at least mean? In this case, at least means greater than or equal to. A lot of people think this means less than, but it doesn't. It means greater than. Let me give you an example that hopefully you'll remember. In order to get into the bar, you need to be at least 21 years old. So in that context, it means you need to be 21 or more. So at least actually means 98 or more. So when I'm looking for the probability that x is at least 98, I'm looking for 98 or more. So 98 or greater than 98. So let's look at a curve. Here's the mean. 98 is over here on the right-hand side. And I'm looking for the probability that x is at least, so it means greater than. So I'm looking for all of this area over here. And it does not matter whether you have the underscore or not, the answer doesn't change. Because remember from the previous page when we were talking about definitions, there is no instantaneous probability. In other words, if I want to find the probability that x is exactly 98, meaning I wouldn't shade any area, I'm just looking for exactly 98, the probability is always going to be 0. You have to create a width in order to have area. Think of it as a rectangle. A rectangle has area, right? But what if this width right here was 0? You would have just a straight line. What is the area of this straight line? Well, the area would be 0. So we're looking for area under the curve. And if you're only talking about one instantaneous line, there is no area, therefore there is no probability. So we're always talking about a range, whether we're greater than or less than a number, and whether you include the line doesn't matter, because it's virtually an invisible line. It doesn't really have probability. Okay, so back to my big graph. We're looking for the area that is greater than 98. So we're looking for this area over here to the right-hand side of 98. So we would add these two bars together, which totals 2.5%. How about the probability that x is between 44 and 98? We're looking for the probability x is between 44 and 98. So if I were to look at a small curve, see 98 is on the right and 44 is on the left. They're not equidistant. 98 is a little farther away. And we're looking for that area in between. Right? So the area in between 44 to 98. Let's go over here and look at the graph. So here's 44 and here's 98, and we're looking for the area in between. So if I added up those three values, you're going to get 81.5%. All right, last one. I'd like you to think about this one on your own. I'm looking for you to find the probability that x is less than 41. Less than means this. So now is a good time to pause the video. I'd like you to draw the curve, see if you can answer the probability. So pause the video and come back. All right, hopefully you were actually a little stumped on this. And that's the reason why I wanted you to do it on your own, because it actually is not, you can't answer it from the empirical rule. So the probability that x is less than 41, the graph is going to look something like this, right? But unfortunately, if we go up to the main graph, 41 is not one of these boundary lines. In fact, 41 would lie somewhere in between 26 and 44. It would lie somewhere right around here, wouldn't it? So it's asking me actually to find the area that x is less than that number, but it doesn't go all the way to the boundary line of 44. So I can't simply just add these three boxes because I'd be adding this little sliver in here which isn't included. So how would we find a probability of a number that is not exactly on one of these standard deviation lines? Well, that's what the rest of this chapter is about. So the answer to this question is wait and see. Okay, so in section 7.2, we're going to start discussing how we can find the answer to questions like that. This section describes how we can find the area under the normal curve ourselves. It will involve calculating what's called a z-score and then looking up the value in a table, or you can use technology such as statcrunch. So that's what we'll use in class here. So the first thing we will do is we will find the z-score. The z-score is nothing more than it tells you how far away from the mean you are. Okay? Suppose a random variable x is normally distributed with a mean and a standard deviation. So this is how you'd calculate the z-score. It's normally distributed with a mean of 0 and a standard deviation of 1. The random variable z is said to have a normal distribution. So let's look at what this would look like in a curve. There are three main types of questions that we will answer. Here are the following approaches. Find the area to the left. So if we're looking for the probability that x is less than some number, we're shading the area to the left. So if we're looking for the probability that x is less than some number, wherever that number is, we're looking for the area to the left of that. So you basically are going to calculate whatever this z-score is. So we'll find the z-score. And then we're going to go to table 5 in the back of the book, or they're also provided to you in the resources of this course. Then we're going to go to table 5. We're going to look up that z-score and we're going to find the probability. Another way to do that is if you wanted to find the area to the right of a number, which means x is greater than some number. So let's pretend that the value is over here. And we're looking for the area to the right of that number. First we calculate this z-score. Then we do 1 minus whatever the table value is. Because the table will always give us area to the left, but we don't want the area to the left. We want the area to the right, so we take 1 minus the probability that you find in the table. This area that you find in the table, which is to the left, we know that the two sides add up to 100%. So if I take 100% and I subtract the yellow area, I'm going to end up with the red area, and that will give me my probability. If I want to find the area between two numbers, such as the probability that x lies in between two numbers, you're going to calculate both of these individual z-scores, find the table values for each, and then we'll subtract them. So you're going to subtract the probability of the bigger one minus the probability of the smaller one. Make sure you end up with a positive number. If you subtract the opposite direction, you end up with a negative. That would be wrong. Probability can never, ever, ever be negative. Remember, probability has to be a number between 0 and 1. Probability can't be negative. Okay? So what we're going to do now at the bottom is we're going to go back and we're going to do the last example that we just finished doing. We're going to do all of those in statcrunch and see if we get the same answers. So we're going to go back and do all of these questions over again, but this time I'm going to do them in statcrunch. Okay, so first we're going to do all of these examples using the table, and then we're going to do all of these examples using statcrunch. So if we were to use the tables to do the first question, first I need you to locate table 5 from the back of your book, or also they can be found online or they can be found in your resources of your course. Table 5 is going to look like this, which is the standard normal distribution table. Okay, so the standard normal distribution table is going to be set up with, along the left hand side, it's going to have z's. Notice they range from -3 all the way down to +3. They don't go outside of that because z stands for standard deviations. Generally speaking, we don't go much past 3 deviations away from the mean because it's very rare that you're going to find data outside there. And then inside of here are all of the probabilities associated with particular z scores. So let me come back to that in just 1 minute. So here I've got an example, finding the probability that the cell phone bill costs less than $44. So the first thing I'm going to need to do is I'm going to need to find the z-score for this example. Okay, so to find the z-score for this example, I first find the equation for z is the data minus the mean divided by standard deviation. Okay, well in this case the x is 44 and the mean is 62. Here we go. I have more room now. So x is 44, the mean is 62, and the standard deviation is worth 18. So that gives me a z-score of -1. So in this question, when I say the probability that x is less than 44, I'm also saying what is the probability that z is less than -1. Those mean the same thing. So if I look back at this graph really quick, here's 44 and it has a z-score of -1. What that means is that this number is exactly 1 deviation less than the mean. Okay? So now that I have this z-score right here, I go to the table, I look up a z, this is the z side here, I look up a z-score of -1.0. These are the hundredths places, so it's -1.00, and the probability is 0.1587. And compare that probability to what we found earlier. Very, very close. This is 15.87%. This was 16%. Very close. They are not a perfect match. And the reason why is because the empirical rule is this blocking method. This only gives approximations. So this 16% is actually an approximation. It's not an exact answer. This would be an exact answer using the tables. So if you're looking for an exact answer, the tables or statcrunch is going to give you an exact answer, where the empirical probability, these blocking methods, are only going to give you an approximate answer. But at least we know we did it correctly because those answers are very, very similar. All right, let's go ahead and finish out the page doing it with the formulas, and then again we'll go back and look at it with statcrunch as well. All right, so find the probability that x is greater than or equal to, or excuse me, just greater than 62. So the probability that x is greater than 62 is the same thing as find the probability that z is greater than some number. So let's find that number. So z equals x minus mean. So in this case it's going to be 62 minus the mean. Hey, the mean is 62. That's right, this number is the mean. So that means my numerator is going to be 0. So that means my z-score is 0. So let's go back and look at the curve real quick. So when you're at the mean, it has a z-score of 0. And that makes sense because this is exactly in the middle. In other words, this number right here is 0 distance or 0 deviations away from the mean because it is the mean. Okay. All right, so let's go now and there we go. Let's go back to the table and let's look up a z-score of 0. Here's a z-score of 0 right here. It has a probability of 0.5. That's exactly what we thought it was going to be based on our empirical probability. And that should match. And it does. Let's try another one. Find the probability the cell phone bill is at least 98. So we're looking for the probability that X is at least 98, which is the same thing as the probability that Z is at least some number. So we have to find out what that number is. The z-score is going to be equal to X minus mean divided by standard deviation. So X is 98 minus the mean of 62 divided by the standard deviation. And when I put that into my calculator, you're going to get a value of 2. So we're looking for the probability that Z is greater than 2. Well, let's go back up to my table. 98 has a z-score of 2. That's because 98 is exactly 2 deviations greater than the mean. We could probably figure out what the rest of these numbers are now, can't we? If the mean is 0 deviations from the mean, this number would be 1 deviation from the mean, 2 deviations, and 3 deviations from the mean. On the other side, if 44 was 1 deviation less than the mean, this number is going to be 2 deviations less and 3 deviations less. So all of these z-scores are going to range from -3 to 3 on our empirical scale. Okay. All right, so let's go back to our table and let's find the probability that Z is greater than 2. So we're going to have to come more towards the bottom of the page here where the positive z-scores are. So here's 2.0 and the probability is 0.9772. But wait, hey, that doesn't match what I have over here. And the reason why is because I'm looking for the right-hand side of the graph. This area, 0.9772, is actually this area over here. Okay? The table will only give us areas, and there's even a little picture at the top. The table will only give us areas to the left of a particular line, not to the right. So this number right here was the area to the left-hand side of 98. So to find the probability on the right-hand side, I have to do 1 minus 0.9772, which is going to give me 0.0228, which does match what I found over here. So this is like 2.3%, and over here was 2.5%. Of course, this is an approximation. This would be a more exact answer. Let's try another one. D. What is the probability that X is between 44 and 98? So what it said in the previous table is we have to find both of these z-scores here. So first, let's find the probability X is less than 44. And then we'll find the probability that X is less than 98 by turning both of those into z-scores. Okay, so let's turn 44 into a z-score. So this is going to be 44 minus the mean divided by the standard deviation. And this z-score is going to be 98 minus the mean over the standard deviation. I think we did both of these earlier, so we really don't have to recreate these because these were both from the previous examples. 44 has a z-score of -1 and 98 has a z-score of 2. Okay, so now what we got to do is look up the probability of each of those independently. The probability that p is less than -1, 0.1587, the probability that z is less than 2, 0.9772. So let's see what we have to do with those two numbers in my graph. So over here in the graph, I'm looking for the area in between. The bigger number, 0.9772, is going to be this whole green area over here. But I don't want all that area. I only want the red area. So that means we have to subtract this yellow area. So we'll do the green minus the yellow, and we'll end up with the red. So this is the green, this will be the yellow, and when I subtract those two numbers, I'll end up with the right answer. Now remember, I should subtract it big minus small. We never want a negative answer. And when I do that and I subtract those two numbers, you're going to end up with 0.8185, which does match what we found over here. But again, remember, this is a approximation. All right, so now comes the last one. We can finally figure out what this answer is. I kind of left you hanging before. We didn't quite figure out what that answer was going to be. So let's go ahead and find it now. Okay, we're looking for the probability. Here we go. Looking for the probability that x is less than 41. So first thing we need to do is we need to turn that into a z-score. How far away from the mean is this? I think we can come up with an estimate before I even do this. Let's go back up to the top of the page here. And we decided 41 was right in here, right? And we know by all the z-scores we've been practicing with, so that means 41 must have a z-score somewhere in between -1 and -2. So just by looking at the map, I know about where that z-score is going to be. So when I do the math, let's make sure I get an appropriate z-score. So z is going to be 41 minus the mean divided by standard deviation, which gives me a z-score of -1.17. Hey, I was right. It is in between -1 and -2, so I did that correctly. So then I go to my table. I'm actually going to put an arrow in here. I'm going to go to table 5. That's not TV, that's table 5. And we're going to look up this z-score to find the probability. So we got to look up -1.17. So here's -1.1, but then I want the hundredths place of 0.7. So where does -1.1 meet 0.07, which is the hundredths place? And it would be this number here, which is 0.1210. 0.1210. So now we can answer this question that we weren't able to do using the empirical rule. So the empirical rule is good only if your data lies right on a boundary line. If it does not, then you have to rely on the tables to find a z-score, to look it up in the table to find the probability. Okay, so now we're going to do all of those one more time. This time we're going to do it in statcrunch. Okay, so in statcrunch, what we're going to do is the first thing we're going to do is we're going to go up to stat, calculator, and then we go down here to normal, because that's where we're going to calculate normal distributions. So for the first question, it says find the probability that a cell phone bill is less than $44. First thing I need to do is I need to plug in my mean. My mean is $62 for a cell phone bill. The standard deviation was $18. And I'm looking for the probability x is less than. Notice it doesn't even give me a less than, because remember, it doesn't matter whether it's underlined, because that probability is 0 at that moment. So I want the probability x is less than $44. And when I compute that, I get the probability is 0.1587, which is exactly what we found when we did it by hand. Let's do it again for part B. Part B says find the probability x is greater than 62. So we're going to change this to greater than 62. Probability is 0.5. And I like how it shades the graph. See how it shows me exactly what's bigger, or the area that's shaded. We're looking for the right side of the graph, not the left. For part C, we're looking for the probability of being at least 98. So that means greater than or equal to 98. See that tiny little red shaded area? It's a very small area. It's a 0.0228, which is exactly what matches with our tables. See, our tables are very accurate. It matches StatCrunch. For part D, we want to find the probability of between. So if you want to find the probability that's between two numbers, not just greater than or less than one number, you have to go up here to the Between tab. So when I click on that, then it will give me two possible answers I can be in between. So I want to be in between 44 and 98. And I find that that probability is 0.8186. We had 0.8185 in our table, so slight rounding difference there. For the sake of your homework, most answers they're going to want probably is going to come from the StatCrunch numbers here, but you should know how to also do them with your tables. And for the last one, we want to find the probability x is less than $41. So let me go back to the standard calculator here. I want to go probability that x is less than $41. And there you go, 0.1217. A little bit different than our table, but still pretty accurate. All right, so let's just do a couple of examples to tie all of this together, and then we'll stop here and we'll do another video for the second half of the chapter. So a couple more examples. Let's say a pediatrician obtains the heights of her 203-year-old female patients. The heights are normally distributed with a mean of 38.72 inches and a standard deviation of 3.17. Draw a picture for each in what proportion of 3-year-old females have a height that is less than 35 inches. So I always recommend drawing a picture first. It's very important to get a visual of what you're doing, so that way when you go to the table, your answer in the table makes some sort of sense. Always start by labeling your mean first. In this question, the mean is 38.72. I'm looking for the probability that a 3-year-old female is less than 35 inches. So 35 obviously is going to be on the left-hand side because it's a smaller number. So I'm just going to randomly draw 35. I don't know how far away it is, but I know it's on the left-hand side. And I'm looking for the probability that this little girl will be less than, so that means the left side, of 35 inches. So I'm looking for this area in here. What is this probability? So the probability that x is going to be less than 35 inches, what we need to do is we need to turn that x, or that raw data, into a z-score. So we're looking for what that z-score is so we can look it up in the table. Once we have that z-score, we can then go to table 5, we can look up that value, and we can get then the answer, which is the probability. So first thing we need to find is that z-score. So z is going to be the data value minus the mean divided by standard deviation. In this case, standard deviation is 3.17. And when I put all of that into my calculator, I get a z-score of negative 1.17. So looking for the probability that z is less than negative 1.17, so I go to my table 5, and I'm looking for a probability of less than negative 1.17. Here's negative 1.1. Here's 0.07 for the hundredths place. So those meet right here at 0.1210. So that's my answer. And of course, you can check this in statcrunch also. I would recommend you play around with statcrunch to make sure that you're getting these same answers. How about the probability or proportion that 3-year-old females have a height more than 42 inches? That was a really bad normal curve, but that's okay. We're just getting an idea in our heads for those visual learners. So more than 42 inches. 42 obviously is going to be on the right hand side since it's a bigger number. So I'm going to draw 42 over here. I'm looking for the probability that this little girl might be taller than 42. So that's the reason why I'm shading to the right hand side this time. So I'm looking for the probability that x is greater than 42. So the first thing I need to do is find the z-score associated with that 42. Well, z is going to be 42 minus the mean divided by standard deviation, which gives me a z-score of 1.03. Notice that it's positive because positive z-scores are on the right, negative z-scores are on the left. So I'm going to put that z-score right up in here. Now I go to my table, table 5, and I look up this z-score of 1.03. Here's 1.0, and here's the hundredths place of 0.03, so we're looking for 0.8485. But when I look at this shaded area, I automatically know that that answer is not correct. This little shaded area is certainly less than half of the graph. So why am I getting a probability that is 84%? In other words, a lot larger than half of the graph. And that's because, remember, when you look up a table from a probability from the table, this number is always going to be the probability that is to the left of a line. I don't want the area to the left of the line. I want the area to the right. So I have to subtract that number from 1 to get the other side. And when I subtract that number from 1, I get a probability of 0.1515. All right, next one. Find the probability that a little girl would be between 35 and 40 inches tall. So 35 is going to be over here, 40 is over here, and we're looking for that area in between. Okay, so over here we're looking for the area in between, so we're looking for the probability that x is in between 35 to 40. So we got to find the probability that z is in between what two values? So we're going to find two z-scores. So let's first look up 35. So 35 minus the mean divided by standard deviation. And that is going to be equal to negative 1.17 because we already did that one up here. And then we have to find the z-score of 40. and that is going to give us a z-score of positive 0.40. So those are going to be the values that I'm going to put in here. So I'm looking for the probability that z is going to be in between those two z-scores. So how I do that in the graph is I look up both those probabilities and then I subtract them. So let's look up the bigger one first. 0.40 has a probability of 0.6554, and negative 1.17, well, we already looked at one up, that was 0.1210. So we're going to subtract those two probabilities. It's going to be then 0.6554 minus 0.1210, and that gives us a probability of 0.5344. So this area in here is 0.5344. One last little thing from this section before I move on to the next section is sometimes we do not actually want to find the probability given a value of a normal random variable. Rather, we want to find the value of the random variable that corresponds to a proportion. In other words, if you look back at these cases that we had up here, you were given a child's height and you were asked to find the probability of something occurring. What if the question was backwards? What if I said, here's the probability, in other words, maybe this child is in the 12th percentile for height. Could you go work backwards and find out what their height is? And that's what we're going to do in these last couple cases down here. Okay, we're still going to do the same thing, we just have to work it backwards. So if you recall from the beginning, in the beginning we were given an x, you turned that into a z-score, and then you went to the table to find the probability. Well, in these we're going to work backwards. You're going to be given the probability, we go to the table to find the z-score, and then we convert the z-score into an x. So using the same setup as above, let's find the height of a female that's in the 20th percentile of height. This is the probability, and we're going to work backwards to find her height. So if we know that the probability is 20th percentile, that's 0.2. I'm going to show it as 4 digits because that's how it'll look in the table. So then we work backwards. Now we go to the table and find the z-score. So we're going to go back to the table. We don't know what the z-score is, but we do know the probabilities. These are all probabilities in here. We're looking for a probability that's close to 0.2. And you're not going to get it exactly. You're just going to look for the number that's closest. So I can see that I'm getting closer here. There's 0.18, 0.19, 0.20. So somewhere in between these two numbers is where 0.20 will occur. So pick the number that is closest to 0.2. In this case, I think it would be this one. This number, which is closest to a 0.2 probability, has a z-score of negative 0.84. So my z-score has a negative 0.84. So I had the probability. I went to the table to find the z-score. Now I convert that z-score into an x. So in order to convert that into an x, I have to use the formula. Remember, z equals x minus mu over standard deviation. Well, let's plug in what I know, okay? I know this time I know the z-score, which is negative 0.84, but I don't know x. This time I'm looking for the x on the right-hand side of the graph, or of the equation. So look at this here. I have an equation for which I need to solve. So we're going to use our algebra skills to solve for this. So what you're going to do is you're going to multiply both sides by 3.17. And then you need to add 38.72. So that's going to give me an x of 36.06 inches. So if I asked you for the last question, what heights make up the middle 90% of the heights for 33-year-old females? So if I'm looking at a graph right here, I'm looking for the middle 90%. This is 90% in here. And I'm looking for what these two values are that make up the middle 90% of the graph. So I know that these two z values will be the same value. One will just be negative and one will just be positive because they're going to be the same distance from the mean. So I know they're going to be the same z value. Well, what I also know is the area on the outside. I know what area is in those two little tails. That means there's 10% left over to split between those two tails. So that means there's going to be a 0.05% here and a 0.05 here, or 5% over here. So in order to find these two z's, I can do the same method since I know that this area is 5%. So just like I did in the last question, let's start with the probability of 0.05. Let's go to the table and let's look up the z-score. So if my probability is 0.05, you can see that they're getting bigger. 0.05 looks like it occurs in between these two values right here. 0.04, 0.05. So pick the one that's closer. In this case, they're both the same distance, so just pick either one, just get a guess. So I'm going to pick this value, which is negative 1.64. Negative 1.64. So then I use my formula. I know that z equals x minus mean over standard deviation. So that means x, which is negative 1.64, is going to equal, z, which is negative 1.64, is going to equal x, which I don't know, minus the mean. In this case, the mean is 38.72, divided by the standard deviation. And when I solve this equation, just like I did up here, multiply by 3.17 and then add 38.72, you're going to get an x value, which is equal to 33.51. Now that is going to be this number over here, 33.51. In order to find the other one, I got to change that z to a positive. So I'm going to do the exact same question, but this time I'm going to turn this negative z into a positive z and resolve this question. And when I do, multiply by 3.17 and add 38.72, we're going to get an x value that is equal to 43.93. So these are going to be the two values that I would be looking for this answer.